Welcome to your second video for Year 10 Maths Probability. In this video, we're going to start looking at these things called unions and intersections. Okay, we're going to break this section into two videos. So this is part one. You're going to need your bound reference because you've got lots of key terms we're going to be taking down. So make sure you've got the title Unions and Intersections, and we will go from there. Okay, by the end of this section, you are going to know the symbols for set notation for a union, the set notation for a section, the set notation for a complement, and the set notation and what sets they actually represent. So we're going to know the set notation for these three things and what sets they actually represent. So when we're looking at a data set on a Venn diagram or maybe in a two-way table, we're going to know these sections, so unions, intersections and complements, and we're going to know what they actually represent. We're also going to know how to use a Venn diagram, as I said, to display the outcomes of two or more events. Okay, so what is a set? Well, it's a group of elements, things. So if we're looking at our experimental probability, it is a group of outcomes of a trial that you've done. You've heard the term sample space because it was in our last video, and we said our sample space were the possible outcomes that could occur. So if we rolled our dice, the sample space was 1, 2, 3, 4, 5, and 6. But our elements are the outcomes of that. Now, so the sample space are all the possible elements in that situation. We, from now on, are going to call our sample space our universal set. So if we're rolling a dice, the universal set for our experiment is 1, 2, 3, 4, 5, and 6. If we're flicking a coin, the universal set is heads or tails. Now we've got symbols for the universal set. So when we look at maths, we have all those different symbols. Well, if we're talking about the universal set, that sample space, we can use one of those units there. Okay. Now, our universal set might have a subset. Okay, we're going to look at what subsets are shortly, but if we're talking subsets, they have that symbol. Okay, so let's use this as an example. The universal set in all of the positive integers up to and including 20. So we've got our universal set symbols. So our universal set, so I'm using the S as our universal set, equals from 1 up until 20, including 20. Up to and including 20. All right, A is a subset of S. Remembering S is our universal set, that universal group as such. A is a subset of it. So in this example, A is all of the multiples of 3 in our universal set. So our universal set was all the positive integers up to 20. So all of the multiple 3's in our set, multiples of 3 would be 3, 6, 9, 12, 15 and 18. And that's how we write that. So A is our subset, and then we write all of those possible elements within those brackets. So A1 is the complement of A. So our universal set were all our positive integers from 1 to 20, up to and including 20. Our subset, A, was all of the multiples of 3. So our complement are then all of the values that are not multiples of 3. So everything that's not your subset. Elements. So these are groups in our universal set. We've already said that. Our last example, so our universal set was all the positive integers from 1 up to and including 20. Our subset A was 3, 6, 9, so it was all the multiples of 3. So 6 is an element of A. 6 is an element in our universal set. And we write that like that. So 6 is an element of A. 9 and 12 are elements of A. All right, our cardinal numbers. The numbers of element in a subset. Okay, so we write that as NA. So the number of elements in A. So our example, A, all those multiples of 3 in our universal set of positive integers from 1, all our positive integers up to and including 20. So how many elements are in our special subset? 1, 2, 3, 4, 5, 6. So we write it like that, and that's what we call our cardinal number, the number of elements in a set. Okay, empty sets and null sets, we write that as this. That means there is not a value in a set. Okay, there's nothing in the set that we're looking at, so we'd write it as that. All right, let's start bringing this together a bit in Venn diagrams. And you've got a Venn diagram here. Let's have a look. So our universal set is A and B. Okay. So you can see A, you can see B. So A is a subset of S and B is a subset of S. And our universal set is A and B. Let's link this to Venn diagrams. So we're doing that. Elements in the intersection belong to both A and B. So you know that with a Venn diagram, any element in what overlaps is something that they both have in common. So that is the intersection of A and B. Now, elements in the union belong to either A or B, so this is the union. The whole Venn diagram itself is the union. Elements that have nothing in common and are mutually exclusive, you see we've got no overlap at all there, so they're just exclusive. There's no intersection with these because they don't share any of the same elements. All right, let's have a go with this Venn diagram. We're going to learn some different language now. So this is where you might want your bound reference, but we'll also work through this a bit in class as well with our bound referencing. So don't panic, just try and follow the video for a minute. Alrighty, so inside this box is going to go our subset. So everything is going in there. So everything in our universal set is going within the box. Anything within our subset A will go there, anything in subset B will go there, and in the middle is any intersection, so any elements that A and B share. Okay, so we're saying our intersection of A and B is there. Okay, now our union of A and B is everything within the Venn diagram. It's not everything within the box, okay? Our union of A and B is everything within the Venn diagram, because we may still have values that don't fit into the union of A and B, and they then go outside. Let's practice this. So we've got our universal set of all the positive integers up to and including 20. Now, subset A, what are these? These are all multiples of 2 by the looks of it, and B are all multiples of 3. Okay, subset A, all multiples of 2, subset B, all multiples of 3. All right, we've got our Venn diagram. So we've got A, B, and S, so our universal set is all within that box. We've got all our values in set A there, all our values in set B, and of course here we've got the values that are our intersections, so the values that subset A and subset B share. So they both have number 6, they both have number 12, they both have number 18, so that goes in the section in the middle. Alrighty, oh look at this. So the number of elements in A, okay, which are only in A. So it says in A or B1 because it's a complement, isn't it? So is 7. 1, 2, 3, 4, 5, 6, 7. I counted them right. So only available in A. And here we've got the complement of A that is in B. So it's saying B only. So this is saying what's in A and is not in the complement of B, and what is not in the complement of A but is in B. All right, so we've got 3 values. And here we've got what is in the intersection of A and B. We've got 3 values. So n being the number, remember. We have all these values down here, though, that don't fall into A, B, or the intersection, but they are still part of the universal set. That's why they're still within the box. And there's 7 values there, so these are the complement, the number of the complement of A and B. So there's 7 values there. Okay, so in the union of A and B, that's all these values here, we've got 13. So if you add the 7, the 3 and the 3 together, we get 13. So that's the union. Remember, that symbol's union, that symbol's intersection. Alrighty, so some key terms that we've learned here. Elements, all of the items in the group. We've learnt the idea that that universal set is all of those elements together. So that's that sample space that we've talked of before. We have subsets of our universal set. We have complements, which are the opposite of a subset. We have cardinal numbers, those total numbers of elements in a set or subset. Our null set, that's that empty set or no value. We've got that intersection where elements of 2 or more subsets are shared. We've got the union, which is all the elements in the subset and union. Then we've got that whole concept of being mutually exclusive, where you've got 2 sets that do not intersect at all. Okay, so that's the end of our second video. We'll look at this a bit more. We'll start bringing two-way tables into it in the next video. And obviously, we're going to look much further into this in class and do some work together on it.